Hello everyone, welcome to the electrical circuit simulation series. In today's session we'll study about the positive clamper using diode and a capacitor. So this is the circuit diagram. The components, the first component as we can see is the AC source. The second component is the capacitor, a 10 microfarad capacitor we are using. Then we have the diode. Now we can note that diode is connected in such a way that the N part is connected to the capacitor, okay, and P part is connected to the ground. Then we have the resistor, 100 ohm resistor, and to complete the circuit we need a ground. So this is the ground which is connected to the P part as well as the other part of the resistor. Now the input signal is, of course, we are using the sine wave as our input. Now let us see the working. We start with the negative half because why we are starting with the negative half, because this is more the significant part where the capacitor charges actually. So what happens is, let us see what happens during the negative half of the AC input. So during the negative half of the AC input, the diode comes in forward bias, so diode starts conducting. As the diode starts conducting, the current also passes through this series capacitor, so the capacitor gets charged in this particular way, that the right side we have the positive charge and left side we have the negative charges. And because the output we also get across this resistor, so we get this output, okay, the negative half entirely. Then during the positive half of the AC input, this is the positive half. So during the positive half of the AC input, the diode is off. The diode goes into reverse bias, it does not conduct, and because it is not conducting, the charges which were accumulated previously during the negative half, they get discharged. And because AC is already appearing, so this AC plus this whatever the voltage, because of the charges we have some positive voltage across this, and because of this AC is raised by some level. So this charging of capacitor and discharging of capacitor, it raises the voltage level of AC to the positive side. So this is what we can see in the waveform. So this is the input and this is the output, which is actually raised by some level because of the charging of the capacitor. So because what this clamper does, this clamper adds a DC component to the original AC. So as we can see, it is raised by some level. So because why it is called as positive clamp, because it is raising the level of to the positive side.
So first of all, we select a waveform generator which will act as the AC power supply. Then we need a capacitor, so capacitor is here. Then we need a diode, we get the diode from here. We connect the diode in such a way that this N side is up, and then we need ground, we connect the ground here, and then finally we need a resistor, so we get this resistor from here. And just shift it counterclockwise. Now we do the connection. So this connected, we connect the capacitor, and then we connect this and this one, and finally the resistor. After doing the connection, what we do is actually this, because of the capacitor and the diode, the input will be clamped to a particular positive value. Okay, so whatever wave we are getting, it is shifted on the positive axis by some amount. So to get this action, to know this action properly, the working of this circuit, we also connect a switch here. Okay, so I just connect a switch here. So this connect in parallel. So what this switch will do, this switch, when we turn on this switch, or when we close the switch, this capacitor is as good as it is not connected, and when we open this, the capacitor will be in the circuit. Okay, so what I want to demonstrate is that how this what this clamper is actually doing, what is this clamping action is. I'll just shift this left and to connect the oscilloscope. I'll just connect the oscilloscope here, and we just need to measure the output, so I'll just put it here. Okay, and then I just turn it on and start this. So this is what output we are getting. Okay, now this output, let me expand this view. So this is the expanded view. This is the working of the clamper. Now how do, what we are just getting a square sine wave, right? We don't see anything new. So I'll just run it. I'll just make this divisions. Okay, now suppose if I close this switch, when I close this switch, you can see this entire wave is shifted down. Okay, when I open the switch, we get the proper action of the clamper circuit. So if I just as you can see, the previous wave, it was here, it was actually, it shifts to the positive side of the axis. As you can see, to this we are clamping, actually we are clamping on the positive side. So this is the base. Okay, but as we open the circuit, now this is the clamping action. So it is clamped, or we can say the entire wave is shifted to the positive side of the axis. So this is called as clamping. Okay, this is how the positive clamper works. So that's all for this particular session. Thanks for watching.